name is Ben Tucker. I'm with Aruba. We're going to talk about SD-WAN today. The heading on the schedule was a little bit misleading, but so if you don't know, Aruba Edge Connect is Aruba's SD-WAN offering, as well as SASE and SSC, and we'll talk about kind of both of those in different sections. I am located in Utah. I'm the SC that covers the Rocky Mountain states, so Montana is part of my area as well. So this is kind of meant to be an interactive breakout session, so if you have questions, feel free to ask. I can answer those as we go through. How many here are familiar with Aruba Edge Connect or know what SD-WAN is or deployed that in some fashion or another? Okay, so everybody knows what SD-WAN is, I think, these days. Basically, SD-WAN is how we manage and optimize the WAN network to get users to applications in the quickest and most resilient way possible, right? And so that's what Edge Connect does. This is our enterprise type offering. Aruba has different various products for SD-WAN. One of them is SD Branch for kind of micro branches, home users, things like that. And then we just purchased earlier this year Axis Security, and that's our SSE offering. Together, traditionally, Edge Connect has done the SASE type applications, and now with Axis we can do that breakout to internet users, the internet directly from those Edge Connects or from home devices, laptops, iPads, mobile devices, etc. So what Edge Connect is essentially it's a hardware device, or it could be a virtual device. It's software that runs on essentially a router. So at its core, the Edge Connect is a firewall. It's a router, and at the branch locations, what we're trying to do is consolidate that hardware so you can replace your firewalls with it, you can replace your edge routers with it, and run Edge Connect back to the data center based on any transport you have available. So our philosophy is we're transport agnostic. So as long as you have an IP address on a WAN interface, we can build an underlay tunnel over it to other Edge Connect devices and route that traffic accordingly. So the premise is that we can, based on policy, route that traffic back to your data center if you need to, or we can break that out to the internet. And we do that on a per application basis or a per packet basis. And we'll get into that a little bit later. So we also support our cloud first organization. So we're built on the best of breed of the SaaS architecture. We work with all of the cloud vendors, AWS, Azure, GCP. We can deploy virtual Edge Connects in those cloud instances and design your architecture around how you guys are deployed in the cloud. So applications that are moving from the data center to the cloud, we can seamlessly tie those in together with your SD-WAN infrastructure so that you now can route directly from the branch to the cloud without hairpinning going through your data center and out your firewall and to the cloud. So, and then secure IoT devices, anything that lives behind that Edge Connect, we can net that traffic and route it out the destination, whether that be the internet or back to the data center. Any questions so far? Anything? Well, if there's no questions, we'll feel free to ask the questions as we go through this. This is kind of a small class. We've got some people online as well. So delivering SASE and Zero Trust Network access, what this means, we're calling this SASE 2.0, where we have our, you have your freedom of choice with Axis SSE, this is your Zero Trust Network access. This can be where we're replacing traditional VPN access in your corporate data center. We can replace this now with Access, so you run an agent on your laptop or mobile device, and we can get you directly to the Access cloud and then to any application you need. And we're reducing the security footprint by doing that. We no longer need to give VPN clients access into your internal networks. We can reduce that security footprint by just giving them access to the cloud, the Access Security Cloud, and then giving them access to applications that they need. So it's no longer something where you just designate a range of IP addresses and say this is what VPN clients get to. We're securing that based on applications now. So the next-gen firewall, talk a little bit about that. This is within the Edge Connect. It has a built-in firewall in it. So we're not trying to replace the firewalls of the data center necessarily, although we can do that. What we're trying to do is at the branch locations where if we can consolidate your firewall, your router, your Edge Connect router, or your Edge router, and put those on an Edge Connect device, and then we just build those overlays back to the data center. We're reducing that footprint for you. Where we have all of the built-in intrusion, IPS, IDS, and application-aware and identity-based next-gen firewall features. And this is all policy-driven from the orchestrator. So one thing we haven't talked about, well, there's a slide that I'll talk about the components of it. But and then the zero trust segmentation. This is for the user and device segmentation. We can do VRFs today. So if you're familiar with the routing world and different VRFs, we can do that with Edge Connect through segmentation and firewall zone policies. So in the example of you buy a company, you have overlapping IPs, we can introduce that with you can bring those into your SD-WAN fabric, put them on their own segment, and then we can NAT those IP addresses until you get those cleaned up and on their own address space. Or if you want to keep it NATed across the SD-WAN fabric, that's fine as well. So the components of our SD-WAN solution, at the top here we have the Aruba orchestrator. This is the policy-driven orchestrator. This is where you do all your configurations. Once you do the configurations here and basically push that down to the Edge Connects. And the Edge Connects, they can be physical, virtual, or in the cloud. The cloud Edge Connects, depending on where they're at, they could be either hardware or virtual. So, and then the last two components here are the advanced security, which includes the IPS IDS functionality, as well as the boost, or our WAN optimization. So WAN optimization is an added feature. It's what Silver Peak originally started out, the company started out as just WAN optimization. So that's the TCP acceleration feature of the Edge Connect. And then the SSE, the Secure Service Edge, this is the Access security feature. So ZTNA, SWG, CASB, and the cloud-based security to manage, control, and monitor user access to SaaS applications. So all of these are all driven within the policy feature set of Access security. It's one user GUI or policy. And so we can do each one of these CASB, SWG, and ZTNA under one policy rule, which is pretty nice. A lot of other competitors, you have to have separate orchestration, separate panes of glass to do each one of these. So SD-WAN with the Edge Connect in the enterprise, again, these are all the features that we're talking about today. The next-gen firewall, the deep packet inspection, IPS, IDS, application user identity with ClearPass, so we can do role-based access now if you have ClearPass. By the way, does anybody have ClearPass in their environments today? Okay, good. And then our DDoS detection and prevention. So application identification, so what we're talking about here is when we identify application, so identifying the application traffic on the SD-WAN is super important. We need to do that on a first packet basis. Otherwise, generally in your policy, if it's the 6th or 7th or 10th packet in a flow, what happens to that first part of that traffic? Is it not being classified correctly, and therefore it's not put into the correct policy, right? So we've done a lot of work in making sure that we capture that on basically the first packet. We call it first packet IQ. And that's all done through the DNS and DHCP snooping of each flow that the Edge Connect sees. So we can ensure that based on that first packet, we're putting the application traffic in the correct policy or overlay, which is super important when we're talking about delivering those packets on time and with the right policy set. So the steering the apps intelligently, improving the app response time, reduce backhaul, save valuable WAN bandwidth, all of these things are due to that this adaptive internet breakout. So when we're talking about an overlay going from one Edge Connect to your data center or back to your data center, we need to determine when that packet comes in, is this an internet-based packet or is this a packet destined for a homegrown application back into your data center? And that lets the Edge Connect decide, are we sending that packet directly out to the internet for internet breakout, or do we need to send it back to the data center? So super important that we capture that and identify that traffic from the first packet. So we get these internet map updates daily from our cloud portal. This is all done every 24 hours so that we ensure that any changes that are made or anything that is added, the Edge Connect knows about that. And again, we get this from the cloud portal. And then the orchestrator pulls and downloads the latest version. And then upon that notification, the Edge Connect loads the latest version. So, okay. So the business intent overlays. Has anybody demoed Edge Connect or looked at the orchestrator before? If we have time at the end of this class, I'll demo a little bit about this. But this, the heart or the meat and bones of Edge Connect is the business intent overlays. So if you're familiar with SD-WAN, you know that what we're doing with our WAN transports is we're building underlay or IPsec tunnels over the underlay networks, right? We're building those IPsec tunnels between Edge Connect devices. The overlay is what captures or defines, or you can think of it as the policy where we capture the traffic, classify it based on application, and tell it which overlay to use. Okay, so for example, DNS traffic, we're going to look for that UDP port 53, put it in the correct overlay, and then based on our settings here is how we're going to handle that traffic. And what you can see from these overlays, so right here we have the real-time overlay, the enterprise apps overlay, and a default overlay. And each one of these is kind of set differently, where we have like a full mesh for real-time, and we have hub and spoke for the other two. And these are all configurable per overlay. You get a max of 7 overlays per fabric. So that's the nice thing about that is based on your application traffic, we can define those overlays however we want. Any questions? Okay, so here's a bigger view of that. So when we talk about the overlay traffic, we're talking about the different link bond. We'll get into the link bonding and how we deal with sending traffic across your specific underlays. For example, we have MPLS, Internet, and LTE on each one of these. And then we have a different link bonding policy. These are this high efficiency, high quality, and high availability are all different link bonding policies. And then we have the internet breakout on the right-hand side. So these are all the applications that we classify. WebEx, Zoom, all of our voice type applications are going to go into real time. And these are all configurable, by the way. You can, based on your own applications or different applications that you want classified in this, all this is an ACL per overlay. And so we can go in there and change that and configure that however you want. And then we're going to either send that traffic out the overlay, or we're going to send it to the internet based on its destination. And that, again, is all configurable, basically. If it's internet address, obviously we're going to break it out. But we can also configure, like, for example, your default overlay, where this is kind of your catch-all. The ACL here usually is accept everything, because we don't want to drop traffic, obviously, unless we specifically want to. But a lot of times, we set this to hub and spoke because we don't want just any internet traffic going out to the internet from the branches without being inspected. So we'll oftentimes send that back to the data center, where the data center firewall will log that activity and then send it out based on the default route. Does that make sense? So path conditioning. So when we talk about path conditioning, what we're talking about is we have several, earlier I said we're basically underlay or WAN agnostic, right? As long as you have an underlay or a WAN interface, that whether that be LTE, broadband, MPLS, dark fiber, it doesn't matter. As long as we have layer 3 connectivity and an IP address, we can route across it. And basically, all we're doing here is creating IPsec UDP, and their UDP tunnels across from edge connect to edge connect. So when we route across the overlay, one of the cool things about Silver Peak is we route on a per packet basis. So if we have 4 different underlays, LTE, MPLS, and 2 internet circuits, we'll send 1 packet down each pipe based on our link bonding policy. So we're going to do a 1-to-1 or 1 packet for each underlay, and then reorder those on the other side. So we're just not utilizing 1 pipe and then going to the next. We're utilizing all available paths and sending that packet. And the other nice thing about that is if, let's say, Internet 2 is having a ton of packet loss, we'll detect that and take it out of service until it corrects itself. Or if it's having a lot of packet loss, we can send parity packets, or FEC packets is what they're called, on the other underlay links to reorder that packet and rebuild that packet on the other side. So even with loss, or packet loss, latency, jitter, things like that, we can correct that on the other end based on using all of the available underlay links. Make sense?
And real quick for dark fiber, because we have a lot of county and city that have dark fiber that's between their locations.
Yep.
Is there still a benefit for
Edge Connect?
Edge Connect in those? And then does it become a situation where you could get maybe smaller optics or something, less expensive optics for?
Yeah. There's still a use case for it because we can do all of the things. The Edge Connect, we can do the packet reordering, the packet loss, the FEC, all of those different things, and still categorize your traffic based on that application and send it down that policy. So there's still a use case for Edge Connect. Obviously, if you have multiple WAN links, then we can use all of those WAN links together, right? But if it's dark fiber, obviously it's point to point. It's kind of a use case, a per use case a design, but we definitely have customers out there that are doing it today.
Thank you.
Yep. So we talked about the per packet load balancing. This is the constant monitoring, the packet loss, latency, and jitter and congestion. So if one of these circuits is misbehaving, we'll brown it out basically, or take it out of service until it corrects itself. But at the same time, we're still going to send those FEC packets based on the link bonding policy, so we can rebuild that if those packets don't actually get there on that link. And then these are the different link bonding policies that we have. So real quick, there's basically 4 of them. High availability, this is basically for your real-time type traffic, voice, video, things like that, where we're going to use the best quality path we have the path conditioning, and then the FEC ratio is basically 1-to-1. So for every data packet that's sent, we're going to send a parity packet, just kind of like 1-to-1 mirroring RAID. It's the same concept. And then as we go down, the high quality, high throughput, and high efficiency kind of have different levels of FEC. Where we get to high efficiency, this is basically just send everything. Bandwidth efficiency is 100%. We're not going to just send any FEC packets here. So here we're talking about the forward error correction, where the parity calculated for packets. So we're going to send data across both links, and we're also going to send parity across both links to make sure that the other side can rebuild those packets. And then packet order correction. One of the big problems that we see with high latency type circuits is path out of order. So especially when you're talking about link bonding, say like on an MPLS and LTE network, I wouldn't recommend doing that because the latency is so different. When you have a high latency circuit and a low latency circuit, the packet order correction can be a real problem. However, the edge connects can or will reorder those packets so that they're delivered on time and in order. So application performance. This is kind of what it's all about, right? We want users to get to applications in the quickest and most reliable way possible. And that's kind of what we've been talking about here. All of these features enable us to do. Let's see. So one of the other features that we have here is for ingress and egress shaping and traffic classes for QoS. So all of those are kind of built into the Edge Connect, and actually the traffic classes we put into each overlay. So we talked about before there was 4 different overlays: real time, default, and I can't remember what the other one was. But each one of those has their own traffic class for QoS profiles, right? So we can classify that traffic and match that traffic based on the traffic classes, and then set shapers for each one of those. So we can shape traffic based on the minimum bandwidth, the max bandwidth, max wait time. All those things you would expect from QoS policies. We can do that on your WAN. And this is just showing the performance over any type of underlay. The brown is showing packet loss, and the green is showing good packet capture. The top is the overlay. The bottom 2 are the underlays. So what this shows is the 2 underlay tunnels, the 2 WAN circuits that we're using, has a lot of packet loss, probably has some latency going on. It looks like it's got about 4% packet loss, but the overlay is completely green, which means we've corrected all of that packet loss, and there hasn't been any loss at all. So that kind of goes to show, and we demo this all the time, where we induce a lot of packet loss on the underlays, and the overlay will completely correct that based on the FEC and the packet reordering. All right. So we're kind of moving a little bit quick here. Any questions? No? All right. So security, this is basically our next-gen firewall features, or feature set out of the Edge Connect. At the core of the Edge Connect, we have the SD-WAN, the routing, advanced segmentation, or VRFs, and then with the next-gen firewall, we have the WAN op, the IPS, IDS, and the ZTNA, or zero-touch network access. And then now with SWIG and the ZTNA, DLP, CASB, firewall as a service, all of these things can be orchestrated directly from the Edge Connect. So one of the nice things about this is if, for example, who all has Netscaler or Netscope or familiar with those? Like, I mean, those are all pretty common in enterprise networks today. So Axis can do all of those things now, and we can orchestrate that directly from the Edge Connect or the orchestrator, where we can build tunnels directly into the Axis cloud. So anything that's sitting behind the Edge Connect can now get to the firewall as a service or the software-defined gateways that are in the cloud. We can direct that traffic directly to that cloud provider now, and we can still do it. And we also do this for Netscope and Zscaler. Like all of those providers, we haven't stopped integrating with those, and we'll always continue to do that. So this is kind of showing what the security policy looks like. So these are firewall security policies or zones, and then this is kind of the matrix view, but we also have a table view, which is maybe a little bit easier to read when you get to something this big. But this gives you a good snapshot of when we want the corporate firewall zone as a source, so from and to corporate to talk to corporate, that's going to be an allow all policy. Whereas if we want, guest Wi-Fi to talk to corporate, that's going to be a deny all. But this is how you go in there and configure those rule sets. So this is showing, we can define these rule sets based on ACL or based on application group or application name. So the match criteria is quite extensive, which I'll show you here in a minute. But these are kind of the built-in applications that we have today, and we can define our own application definitions for Edge Connect. So it's pretty intuitive how we get these updated. So you don't have to keep track of all of the Office 365 domains and IP addresses and all of those things when you want to match on that criteria to send those SaaS apps out to the internet. So the policy engine, again, I was talking about application group and application. So when you go in here and you click on that more options, it gives you a pretty detailed list of match criteria. We can do address maps, domains, geolocations, interfaces, DSCP values, source and destination IP subnet, port, anything you need to match that. Anything you would normally have in a next-gen firewall is going to be here in this policy. And then we can also do the role-based access. So if you have ClearPass, roles, posture, user devices, groups, domain, MAC addresses, all of that information is available to us to match on, and then set the policy accordingly. So the IPS IDS function or feature is kind of a new feature set for Edge Connect. It came out in 9.2 beginning of this year. It's a pretty powerful inspection engine. So we can now do with this feature set enabled, instead of just allow and denies with the security policy, we can do allow and inspect, allow and deny, or allow and inspect. And we can see here, we can inspect based on ACLs, allow everything else, and then move on from there. So it's a pretty nice way to turn that into IPS IDS if you need that functionality at the branch. And the allow IDS rules work just like the security policy rules. And then these are kind of the threat feeds that we have, the threat logging to centralized locations. And then the threat logging to central is coming. It's on the roadmap. I don't know. They haven't told us yet what release that's going to be in, but we're told next year. So advanced segmentation or VRF. Talked a little bit about this. Everybody familiar with VRFs today? Kind of. So VRFs in the routing world today is just a separate routing domain. So when you have a set of routers, those are all in one routing domain. The IP address, the routing table is it's basically one routing table or one routing domain. Whereas when you have VRFs enabled, you can have two different or multiple different routing domains. And I used the example earlier, if you have a corporate network and we buy a spinoff, we need to give them access to our applications at our data center, but they have IP address space that overlaps with our corporate address space. How do we give them access? Well, typically we just NAT that traffic and let them on their way. But if that NAT traffic can get quite extensive, in the SD-WAN world, we can put them in their own VRF, so their IP addresses stay isolated from everybody else's, and then we can route leak and NAT that traffic between VRFs. So that's one way to do it. Or you may have like IoT devices that need to be, or PCI devices, PCI compliant devices that need to be completely separate from the rest of the network. Nothing else can touch those. One way to do that is by VRFs. We can have, I think, 64 different VRFs. I have to check the limit, but it's quite large for the fabric, and we can include these VRFs based on overlays, or so if we want, let's say the internet overlay to have the default and voice and include, and then we can skip the rest. You can define that based on overlay, so you don't have to give your segments access to all of your overlays. And again, that's pretty configurable. Any questions on that before we move on? No? Okay. So access security. Again, this is we purchased access earlier this year. It completes our SASE plus SSE portfolio. The components of access are the ZTNA, CASB, SWIG, and the DEM, or Digital Experience Monitoring. ZTNA, this is the Zero Trust Network Access. So this is where if you have traditional VPN access today, the problem that we saw with it was you're giving client access to data center resources based on network ranges, right? So typically you assign basically all of your data center network ranges to your VPN clients, and they can access, even though they only need specific access to specific applications within that space, you're giving them access to the whole range. So today, with Zero Trust Network Access, we're basically taking the role of only give them access to the applications they need. Don't give them access to everything in your data center anymore. And we're doing that, and we're also doing that by reducing your footprint, so that they're gaining access from the client to the Access Cloud, and then we're defining which applications in the Access Cloud they need access to. So that basically allows them to go from the Access Cloud, get authenticated, and then directly to the applications you need in your data center. So CASB, this is the Cloud Access Security Broker. This is for private SaaS applications, data loss prevention. The example that we like to use is, for example, if you have a Dropbox and you have sensitive HR information in there with, let's say, credit cards or whatever it may be, you want your dev team to be able to access that and only look at certain files without downloading any files. So we can set that policy to have them just view certain files within, let's say, Dropbox, but you can set a policy to not allow anybody to download that. So it's quite powerful when we're talking about this data loss prevention piece of it. And then SWIG is Internet Access or Secure Web Gateway. This is to secure and protect against malicious online threats. this is where we do the URL filtering, the inspection, gambling and porn sites. We deny that, DNS control, SSL inspection for malware. And again, this is all, we can set this, there's a couple of different ways we can give you access to access. I probably shouldn't say that. So if we have users that are sitting behind the Edge Connect at your branch office, again, we can create that tunnel up to Access Cloud and do all of these policy configurations. But we also can give you a client to stick on mobile devices as well as their laptops, so they can go directly, if they're home users or whatever and not behind an Edge Connect, they'll authenticate and go directly to the Access Cloud and hit these policy sets, okay? The other nice thing about Access that we haven't really touched on is agentless connectivity. So let's say, for example, you have contractors that need to have access to a specific application for 1 day, or 8 hours, or 8 hours per day for the next week. And we don't have access to their laptop, we don't control it, and you don't want to control it. So we can give them a portal access to that application through this policy-based engine, and give them access to whatever application you need it to. You can do it on a time basis for the next 8 hours for these specific days. And then that way, and then you just give them a link with the username and password to authenticate, and then you're done. And when that time period expires, that portal goes away, and that's all you have to do. So it's really slick if you have those type of contractors or employee needs where you don't want to touch their laptop. Okay, and so, this is just kind of wrapping up everything we've been talking about, where we have the Atmos SSE platform. This is Access with this logo. And then we have the Edge Connect SSE, micro branch or SD branch, and then, or this is SD branch, that's micro branch with Edge Connect SD-WAN. So these are kind of all of the different providers or platforms that we have as a solution for the Atmos SSE platform. And that's all I got. You guys were pretty easy. Any follow-up questions? Anything you guys didn't hear that you want to hear about? We've got a couple minutes left.
Hey, Ben, real quick, you mentioned giving a link, URL.
For the port?
Username and password.
Yep.
Is there a way to enhance that security, multi-factor auth or something like that? Or?
There is, yeah. We can definitely do multi-factor authentication for those, and that's all done in the policy engine. So yeah. Okay. Yep, you can give them a username and password with whatever two-factor authentication you guys use it in-house, and then you can use that as well. So, yeah. Anything else?